Hi, and welcome to 1.6H, adding vectors by components and subtracting vectors. This is an honors topic. Students will be able to add vectors by components, and then students will be able to subtract vectors. So it's like a 2-for-1, and then you could even subtract vectors by components. Oh man. So now that we can resolve vectors into their components, we can add vectors together that are not at right angles. These two vectors aren't at right angles, so we cannot just use Pythagorean theorem, sine, cosine, and tangent. We could try to graphically add them if we can use our ruler and protractor and kind of go like this, do head to tail, and then our resultant should look like this. So we can definitely make a scale drawing and measure them all out, like how many degrees is the blue vector from north and all that. But you could also do it mathematically, and here's how you would have to do it. You'd have to break the blue vector into its x and y components, and break the green vector into its x and y components, so that now we can add the y components together and the x components together. And how do you add vectors? Head to tail. So let's move that green y component vector head to tail with the blue y component vector. And then we'll do the same thing with the x components. So now we could add the vectors together, and from start to finish, so in the y, start, then we went up, came down here, finish, the resultant is small. It looks like this. And in the x direction, start to finish, you get a resultant that looks like that. So now we have the resultant in the y direction and the resultant in the x direction. We have to make another right triangle, head to tail, draw in our resultant, and then that's the answer. That's how you do that. You can see when you add the green and the blue head to tail, that's the resultant. So it's a lot of steps, but it's basically all the same thing. It's just trig. So I'm going to use the graph method for this. I'm going to draw it out. And on the next slide, there's an easier, kind of cleaner way to do it with an XY table. But here's the situation. Vector A has a magnitude of 10 units, and its direction is 30 degrees above the x-axis. So the way you think about that, you have like an x and a y graph, and then 30 degrees above the x-axis looks something like this. All right, and then this is going to be 10 units. So I'll draw this on the side. That's what vector A looks like. Vector B has a magnitude of 15 units, so it has a greater magnitude, and its direction is 60 degrees above the negative x-axis. So the negative x-axis is this side, and we're going 60 degrees above. So it'll go in something like this direction. Now I'm not using a ruler and a protractor, but you get the idea. So now we want to find the resultant of the two vectors, and the first step is going to be to break them into their x and y components. So we have basically two hypotenuses right now, and let's make them into right triangles. So I'll draw the x component of the a vector, and we're going to call that a sub x. A sub x. Then we draw the y component of the a vector, and we'll call it a sub y, and just like that we have our right triangle, and we can break them into components. I'll draw the bx and by. So far so good. We're basically just doing two component problems. So I'm going to use cosine to find ax, because this is adjacent hypotenuse, and I'll use sine, this is opposite, and hypotenuse to find ay. I'll do the same thing for bx and by, and I'll just write in the numbers. So at this point, you should be pretty fast with the trig stuff. There is a shortcut if you wanted to. You can write ax is equal to a cosine theta if the angle is adjacent to the x component. And because you know that's basically just cosine theta is equal to adjacent the hypotenuse. And then you cross multiply and you get ax is equal to a cosine theta. And you could do the same thing for sine. Sine ay is equal to a sine theta. So I do those super quick in my calculator. You can just do 10 cosine 30, 10 sine 30. So now we have some work to do. Since we broke it into the x and y components, we can add ax plus bx together because they're in the same linear path. And we can add the y's together. Let's start by adding the y's, and I can either make an xy table, which I'll do next, or I'm going to show you what's happening in the background of that xy table. I'm going to redraw ay, and then I'll add by head to tail. So that gives us a resultant in the y direction of 18. So you could make this is going to be the y component of our answer, of the resultant. So this is just a part of the final answer. This is the y part. I'm going to call the resultant r, and this is r sub y is equal to 13 plus 5, 18. I kind of drew it there. 5 plus 13 equals 18. Okay, so now we are going to add the x components together. This one and this one head to tail. I'll start by drawing the ax at the head of our new resultant. So we'll call this a sub x. And be careful because b sub x is actually pointing to the left in the negative x direction. So it would be better to call this negative 7.5 because it's going in the negative x direction. And when we put the tail of that vector on the head of vector A, it points to the left. So we have to draw, it's overlapping and canceling out. So b sub x is equal to negative 7.5 because it's going in the negative x direction. It's going to the left. And a sub x is equal to 8.66, and the resultant of the x components goes from start to finish right here, and we have r sub x, and r sub x is equal to 8.66 minus, or we could say plus, negative 7.5. So r sub x is equal to 1.16. Now it's going to get a little messy here, so I'll erase that and make it a little smaller because we have to draw in our resultant. We have the x component of the resultant and the y component of the resultant, but we need to draw from start to finish the actual resultant. So that's out of our way, and we're going to go start to finish with this big triangle. This is the answer. This is the resultant. And now we just need to do some trig because now we have a big right triangle with an x component and a y component. So we need to do Pythagorean theorem. Plug in the components for a and b. And you get a magnitude of 18.04. So since Rx is super small compared to Ry, it's very close to the y component length, but it's a little bit bigger because it's the hypotenuse. So 18.04. Now don't forget, we also have to find the direction. So let's find the angle. That's fun, right? We'll do the inverse tangent. And you get about 3.7 degrees. So after all that work, our resultant is 18.04 units. 3.7 degrees east of north. Now, drawing the y and the b together, I think it's good to illustrate what's actually happening and the x components together, but there's an easier way. It's a little messy like this. So you could also do a table. So especially when you're doing the table, because you're not drawing this out, anytime you see a vector pointing to the left, like bx, you want to make it negative right away. And if a vector was pointing down, then you would also make that negative because it's in the negative y direction. And I'll show you why. So here you make your xy table. And on the left column, you'll write the name of your vectors. So we'll have A in that row, and then B down below. And we can even make, like, we're going to sum them up. And then we'll find the x and y components of our resultant. So when you draw in the AX is 8.66. And AY is 5. This is much cleaner. And then BX is negative 7.5. That's the drawback, is you have to remember if it's going to the left or down, you have to make it negative. That shows that the vectors are pointing in opposite directions. And BY is also pointing up, so it's positive 13. Now, to find the x components, all you have to do is add these numbers together. And if you drew in the negative sign, you still just add it. So 8.66 plus negative 7.5, you still get an x component of 1.16. And your y component is 5 plus 13. So there's our 18. And now at this point, if you wanted to, you can draw your triangle with your x and the y components, and then you can do your trig. So our x is positive 1.16, so that means it's going to the right. And our y is positive 18, so that means it's going up. Now in the previous, I had them, because I graphically did it, and it just worked out that I had it like this. But isn't it the same thing? So R goes from start to finish. That's like the parallelogram method. So we're still finding R, and we still have our right triangle, and we have to do Pythagorean theorem. Oh, and I'll get a different angle because it's a different, I didn't draw this one. So it might look like a different answer at first, but this one's going to be north of east, and it'll still be a valid answer. So you get 86 degrees, 86.3 degrees, and that's going to be north of east. So you could also solve that way. So our answer looks like this. And yeah, I like the table method better, but it's not as intuitive. Sometimes people need to really draw these vectors out to have it make sense. Again, the most important part is if it's going to the left or down, you want to make those values negative. So we could also subtract vectors. So it's not as complicated as the adding vectors by components. All you do is when asked to subtract vectors, you flip the direction of one of the vectors to make it negative, and then you add them together. So if I have the green arrow pointing to the right and the blue arrow pointing up, we add them head to tail like normal, and then we have the resultant. Well, if you were asked to subtract those two vectors, the first step is to flip that vector. We want to flip that second vector. So the green minus the blue, so you have to make that blue one negative. And then you add them head to tail like that. So can you picture in your mind what it would look like if those two vectors on the bottom were head to tail? Looks like this. And then you draw in your resultant, and you can see the resultants are different. This one's pointing to the right and up. This one's pointing to the right and down because we're subtracting them instead of adding them. So for vector A, we have a magnitude of 12 units east. And vector B has a magnitude of 16 units north. So if we wanted to do A minus B, we'd have to redraw B, and we'll make it negative 16. And now we'll use these two to find our resultant. So we draw head to tail, A to the right, and then B going down, and the resultant is still from start to finish. And we have our right triangle, and it's 12 and negative 16. So then we do Pythagorean theorem. You get a magnitude of 20. And then when you do theta, you do the inverse tangent of the, we'll find this angle, opposite over the adjacent. But you make them, you just make it positive when you're doing that. And you get an answer of 53 degrees. Right here, so this is 53 degrees. So your answer is 20 units, 53 degrees, and we could say south of east. So now we could subtract by components too. Vector A has a magnitude of 13 units and its direction is 40 degrees west of north, so that looks like this. B has a magnitude of 10 units and its direction is 10 degrees south of west. So if you were going to subtract those two, you'd have to flip A. If it's A minus B, you got to flip B. And I'm going to draw flipped B this way. And this is alternate interior angle. So B, the magnitude is the same, it's just pointing in the opposite direction. So that's how you would do that. And now our objective is to add these two together. Since they're not at right angles with each other, we have to add them by the components. And I'm saying add because we already flipped it. So we're still overall subtracting A minus B, but now this is like negative B. Okay, I'll break these into components. And take note, because they named this angle here, I drew the triangle like this, and AX is opposite the angle that they described, so I can't use cosine because it's opposite. So that little shortcut doesn't always work. It's going to be AX is equal to A sine theta, and AY is equal to A cosine theta. Now AX is pointing to the left, so you have to make sure that you make it negative. AY is pointing up, so it's okay if it's positive. I'll break B into its components. And in this case, it's business as usual because the X is adjacent to the angle that they named. So we could just do BX is equal to B cosine theta and BY is equal to B sine theta. And at this point, I always check, are they positive or negative? Bx is pointing to the right, so it's positive. By is pointing up, so that is positive as well. And now I'm ready to make my XY chart. I'll plug in my values for A. So AX was negative 8.36, and AY was positive 9.96. For B, we have BX is positive 9.85 and BY is positive 1.74. To find the X and Y components of the resultant, you just add the numbers together. So for Rx, you get 1.49 in the positive direction. And for Ry, you get 11.7, again in the positive direction. At this point, we can draw our triangle. Make sure you connect Rx and Ry head to tail. Your diagram might look a little different from mine if you drew Rx on top. And now we're ready to find our resultant. using the Pythagorean theorem, and we're going to find this angle with the inverse tangent. So you get an answer of 11.8 units, 82.7 degrees north of east. And that's about it. Have a great day. Thanks for watching.